So that's one of the priorities that I've observed. Another one is, which I'm going to talk about today, is reducing costs. So I just want to do a quick check. At the back, can you hear my voice?
Yep.
Good. Okay. So let's begin with cost optimization within Amazon ETS before we jump right into the main talk. So it is interesting to let you know that right now, customers using or building their Kubernetes on Amazon ETS, because of that singular decision, they are already saving huge amount of cost. Because when you compare running a traditional Kubernetes cluster, let's say self-managed Kubernetes cluster, and you compare it to Amazon ETS, you're already saving about 10x your cost when you compare. The time is short, I wouldn't really go into that comparison just because of the time, but let's explore some of the strategies that will use the saving cost. So whenever I give talks like this, I like to share my own personal experience so that I can make it relatable. Before I joined Amazon, I used to be an Amazon customer, and I was struggling. I wanted a salary increase. I wanted a raise. So I've explored all the possible options I could, but I couldn't find one. And luckily, I was going through a personal development, was a course called Cloud Economics. So from that course, I learned a few tips on how you could optimize costs operating on AWS. So I did the financials, I did the numbers, and I just went to my CFO and I said, oh, I want a raise. And he was like, what do you mean? Go. So, okay, and then I started sharing the number that, okay, going into the next year budget, I could save you about 40% of the current cost that we do in here. And he was like, okay, let's go through the numbers. Now, that gave me a bargaining power. Out of the 40%, please, I'm not asking for too much. I was asking for 10% of the 40%. Was I asking for too much? Okay. So the examples I'm going to share here are some of the examples I followed back then. So the first one is hardware, right? So when you look at hardware, it talks about the kind of processors you are selecting. When you're as little as making the decision of which kind of OS, which kind of hardware should my OS be, you can start your cost optimization journey from that decision. So the next one is purchase option. We have so many purchase options, but which one are you choosing? Do you know why you're even choosing the one you're choosing? We also talk about cost observability and scaling. These four simple strategies, if you can follow these four strategies, you'll be able to save your company or yourself cost, because I know some of you run Kubernetes cluster in your test environment, so you can also save yourself money. So let's start with hardware, right? One common processor that many people don't really pay attention to is Graviton. Graviton processor is Amazon built processor using 64-bit ARM Neoverse cores. When we have two types of bits, Graviton 2, Graviton 3. If you're running Graviton already, compared to running the normal Intel 32 bits, you're already saving yourself about 40% cost and also in terms of performance. But if you also want to take it a little bit further, maybe you have a complete intensive use case, you can also use Graviton 3. So maybe you've not tried building your workload with Graviton, you can explore that option. Another one is purchase option. Amazon, as it is right now, we offer 4 different purchase options. The first one being on demand. So on demand option is if you want to do pay as you go, and you have a very short short time workload, you're not running it for a long period of time, you can use on demand. That's the common use case of on demand. But even someone that wants to do a long running workload, maybe the person doesn't really know to explore another option. So that person still use on demand. But we will see how we can also save costs for that particular use case. Another option is reserved instance. So this kind of purchase option is ideal for long running. So if you have if let's say you have a SQL database workload that you want to use to build warehouse, and it's going to be running for 6 years, it makes sense for you to just reserve that instance compared to running on demand. So that's one of the saving opportunities that you can also apply. Then we also have saving plans. Saving plans is similar to on demand, but there's no long-term commitment required. So you don't have to commit to AWS and say, oh, I'm going to commit this certain amount. That's just a different between the two. Then the fourth one is spot instances. How many of you are familiar with spot instances? If you good. With spot instances, you can save up to 90% of your costs. Before November 2017, how you get spot instance on AWS platform is you have to bid with other people also demanding spot instances, but that's not the case anymore. So as long as there's compute capacity available, you can always use spot instances. So imagine you saving 90%. That was the first argument I brought up to the CFO. I just mentioned, I could save 90% if we're doing spot instances only, but we couldn't do spot instances only because we have other use cases that on demand makes better sense and better value. So we've talked about spot instances now, but yeah, I would also like to mention one, if you're building on spot instances, one thing you need to be familiar with is that because it is based on availability, you might run into interruptions. Your spot instance might just go off, but depending on how you are building or what you're using to build, you can always implement interruption handling. We'll talk about that further down the line. So with interruption handling, you get like 2 minutes notification that this instance is going to be shut down. Then you can automate how you want to transition your workload or migrate your workload to another available compute. So how do you save costs if you don't have visibility? If you don't know what you're actually spending? So you need cost visibility, right? If you're running Kubernetes cluster, KubeCost is an open source solution that you can actually leverage on to give you that visibility in your cluster. So you can just easily install it. You get optimization and savings recommendation. Then you can also implement some governance. If you have a very regulated environment, you can build some custom rules to implement some governance with KubeCost. So if you have KubeCost in your environment, you get a dashboard like this. I mean, C-levels, executives, they like kind of dashboard. How many of you agree with me that they like dashboard like this? This is the only way you can communicate with the business decision makers. This is how you can convince them that, this is what we're spending, and this is how we can save cost. So lastly is scaling. If you want to save costs, running Kubernetes, if you pay attention to just scaling alone, you've done about 70% of the job, because your Kubernetes workload runs on compute, And you don't want to over-provision, you want to right size. So when you're doing that, you're thinking of scaling. It's better you start from one and you have scaling implemented that will grow gradually as the workload grows, rather than over-provisioning without any informed decision. So I'll talk to you about HPA, VPA, cluster autoscaler, but let's do a quick quiz in the house. So who can just try? What is HPA? Have another mic. I need another mic, please. Okay, HPA, that's done. What does HPA do? What does HPA do? HPA is something. Interesting. Okay, how many of you are familiar with carpenter? Now, don't tell me DIY. So, how many of you are familiar with carpenter and what you can do with carpenter? You don't know? Oh, wow. Okay, if that's the case, let's do Kubernetes autoscaling 101. Let's start from there. We'll start from the basic. I just have like a few minutes to cover that. So when we talk about HPA, that's horizontal pod autoscaling. So in Kubernetes, you have your workload, then you have your compute. With HPA, you are handling the scaling of your workload. So you start, you architect, you build for an event, you start with 10 pods. And when the event keeps going on and you have more viewers, more requests coming in, HPA helps you to grow that number of pods from 10 to maybe 20 or 1,000 for as many as you've configured it to handle. So HPA helps you to scale your workload. So now, what about VPA? So vertical pod autoscaler, the answer is right there on the board, but what does it do? It helps you with right sizing, right? Once you launch your workload, you don't know what is the recommended CPU or memory request that you need. But with VPA can give you that recommendation and spins up another pod with the right new configuration in terms of resource utilization for your workload. Now we have cluster autoscaler and we have carpenter. And what that does is it helps you to scale your compute, the underlying compute that your pod runs on. Okay? So that's just it. Do we all get that now? Good. So let's talk about carpenter. Just briefly, I'm glad that there's another speaking session that talks about carpenter heavily. But if you're using carpenter, there's a feature within carpenter that you can use to also save costs, to also optimize, and it's called, what's it called? Who can guess? Okay, good. It's called consolidation. So how does consolidation works is that it helps you to look at the amount of nodes that you have running in your cluster. If there's a node that is underutilized and there are pods running on that node that could run elsewhere, it will swap those pods to the other node and shut down that node. So if you're using Carpenter right now, you can also use consolidation. So let's look at the example here. We have 4 instances running, okay? And on that 4 instances running, we have just 2 with 1 single pod running. We all agree that these 2 pods can run on this node, right? The node with 2 pods, okay? So once you turn on consolidation, look at that flag, it says when underutilized. So your carpenter has a watcher that detects that these last 2 pods and these last 2 nodes are underutilized. So let's see what's going to happen. Now, it's eliminating those 2 nodes, swapping those 2 pods to the other running pod. There's another thing Carpenter also does, is we have 2 M5X large instances. So Carpenter can also evaluate again and see, oh, can this two workload run on a smaller instances? If you compare M5 large and M5X large, that's a 2x saving when you downgrade from those instance family type. So you have 2x savings already, and that's what you can get out of Carpenter consolidation. So let's talk about the other questions that I do get asked often is, how do I shut down a workload in my cluster just to save money? And if you can also interpret the word shutdown as scaling, right? Shutdown might sound a little bit aggressive, but it also means scaling down to zero, meaning that I want to run zero workload and not pay for anything. So beginning with cluster autoscaler, right? Cluster autoscaler is tightly integrated with Amazon EC2 autoscaling. It uses EC2 autoscaling, and anytime you have a node group is simply just telling you that a group of nodes that runs on an EC2 autoscaling. That's what it means, right? And how you can save costs doing that is whenever you have off-peak business period, or maybe weekends, and you want to shut it down, the recommended approach is to scale down the autoscaling group to zero. You can scale it down to zero. And when you do that, in EKS, for example, is that your node will be drained, then it will be terminated. So during the period where maybe you're running 5,000 development clusters and maybe you're going on holiday for whatever reason, and you'll be back in the next 1 month, but you don't want to run and incur those costs, you can just scale down to zero. And how do you do that? Here's a simple command. Using AWS CLI API, you can scale down to zero. You can see a schedule here that says COB, close of business, at 6 o'clock between Monday to Friday, scale down my autoscaling group to zero. So that way, you don't incur any data plane costs. So if you look at what your in-cluster would look like, this is what it looks like. When you run kubectl get nodes, you won't see any resources, okay? If you also try to get pods that are running, you won't find anything. And if you look at the costs during that period, you can see that that's $00 per hour and per month. So you have this cluster originally was configured to run 24 workloads, meaning 24 pods. So when you scale it, this is what the cluster will look like. So what if I'm not using cluster autoscaler and I'm just using Carpenter? How do I do that? With Carpenter, my recommended option is to use cron job. How many of you are familiar with cron job? We are all familiar with cron job. Starting from Windows, Linux. So in Kubernetes as well, you can also use cron job, okay? So when you use cron job, you can automate your task, write a cron job that runs a pod that terminates all the pods that runs in your cluster. If you have deployments, you can scale in those deployments to zero. You can do the same for your stateful sets, delete your stateful sets, okay? So here is just an example of what's currently going on in my own personal test cluster. I have a few of those clusters. So you can see in the morning, 9 o'clock, when I start my work, this is what I'm running out. There's a pod that runs. But if you ask me, okay, there's no node. I was expecting someone to ask that question. There's no worker node in my cluster. So how does the pod get to work? Because every single pod needs a node to run, correct? Yeah. Mm-hmm. So one way you can do that is you can use Fargate. Fargate is a serverless compute. You can also save costs with Fargate as well, because Fargate spins up the right amount of worker node you need to run your workload. So in that case, my cron job is going to schedule a pod that runs on Fargate. Fargate is serverless compute, right? So that pod will run, then you'll be able to execute this cron job when I need it. If you're not using Fargate, you can have a dedicated worker node in your cluster, then you can taint the worker node so that the node doesn't get deleted. The only job that node does is to keep running, to run your cron job automation in your cluster. So, okay, you've seen the cron job, but what does it look like? Now, this is what it looks like. During scale down, this is what a scale down cron job manifest looks like. You can see the schedule. You can see the bash script there. The bash script is simply doing kubectl scale to 0, all my deployments, okay? So it's scaling down all the deployments I have in the cluster. It's a long bash script, but you get the idea. So during scale out, I'm also doing the same thing, okay? So during scale out, you can see the schedule is different, but this time around, I'm scaling the replica, I'm increasing the number of the replicas in the cluster. So let's look at what the cost looks like. This is my typical cluster when it's in full operation, okay? And you can compare the cost when I scale it down. It comes to 0, from $94 to 0. So this is just a very small cluster. It's made up for a demo, right? You can imagine what a very big cluster would look like. So if you don't want to go through the headache of creating your own cron job and the manifest and the likes, there are ready-made solutions. I mean, that's one of the reasons why I love Kubernetes. There's so many contributors from the crowd here, myself, everyone contributes. So you can use these two available solutions to implement an intelligent shutdown in your cluster. So my final recommendation is, we've talked about the scaling. If you want to save cost or to scale, you can run Fargate as well for right sizing. Make sure you have Container Insight. Container Insight is just gives you observability into your cluster. We've talked about right sizing with VPA, okay? Cube cost gives you cost visibility, gives you cost optimization recommendation. Then make sure you always choose the right AWS instance. They want to use ports, they want to use on demand. We talked about processor as well. What Graviton can do for you, you can save a lot of cost with that. So also storage, which is something I didn't get to talk about. The default storage, if you're building cluster, is always GP2 on Amazon. But you can also use GP3. GP3 gives you better cost savings compared to GP2. So always use port instances. Then make sure you tag. If you use tags, you'll be able to allocate which cost your group of teams are using. So for additional resources, you can scan the barcode here. It takes you to some of the available links where you can learn more based on all that I've discussed earlier on. I'll give you like 1 minute to just take a screenshot if you want. Okay, thank you.